Hey class, we're starting a new chapter today, chapter 7, applying the Pythagorean Theorem. The Pythagorean Theorem is something that you're all pretty familiar with, so everything you see here may be a review. Let's start today by reviewing an algebra concept, which is squaring square roots. Let me do the first one, just in case you've forgotten. The square root of 5 squared would be the square root of 5 times the square root of 5, which yields the square root of 25, which equals 5. So if you guys kind of remember the shortcut, whenever you take the square of a square root, so the square of a square root, it actually ends up equaling the number inside. So what's the square root of 8 squared? Hopefully you said 8. Let's do 2 more. 3 square root of 6 squared and 2 rad 3 squared. Feel free to press pause if you need a moment. Three rad 6 squared would end up equaling 3 rad 6 times 3 rad 6, which equals 9 times 6, which is 54. For 2 rad 3 squared, that would be 12. Let's move on. The Pythagorean theorem only applies to right triangles, right? And we know that the Pythagorean uses the variables a, b, and c, where a and b have to be the legs of the right triangle, and then c has to be the hypotenuse of the right triangle. The hypotenuse being the side that's opposite the right angle, or the longest side in a right triangle. So you can see here in my right triangle, I've labeled A, B, and C, C being my hypotenuse. And we know that it's always true in a right triangle that A squared plus B squared equals C squared. So in other words, the sum of the square of the legs of the right triangle equals the square of the hypotenuse. Example 1, find the length of the missing side. Feel free to press pause. So I'm going to start with my Pythagorean theorem here. A squared plus B squared equals C squared. I'm going to plug in x for A, so that would be x squared. I'm going to plug in 12 in for my B, because that's the other leg, 12 squared. And then I'm going to plug in 13 for my hypotenuse, because I know that's my longest side, or the side that's opposite the right angle, 13 squared. X squared plus 144 is equal to 169. X squared equals 25. So x has to equal the positive square root in this case, because we know we're talking about a length of something, or a length of a triangle. So it's the positive square root of 25, which would be 5. This leads me into a conversation about Pythagorean triples. 5, 12, 13 is an example of a Pythagorean triple. You want to probably start committing that into your memory, because this works for all right triangles. We're saying that 5 squared plus 12 squared equals 13 squared, always. These integer values will work, and a squared plus b squared equals c squared. Some other popular Pythagorean triples that you might want to start memorizing is this one right here, the 3, 4, 5 Pythagorean triple. To prove it to you, I can show you that 3 squared plus 4 squared is going to equal 5 squared. 9 plus 16 equals 25. So this Pythagorean triple always works. But not only that, the multiples of the Pythagorean triple also work. So for example, if you guys look at 6, 8, 10, that's just this Pythagorean triple times 2. 9, 12, 15 is the Pythagorean triple 3, 4, 5, but times 3. 30, 40, 50 is this Pythagorean triple times 10. 3, 4, 5 is the one that's the easiest to memorize. Oops. Here's 5, 12, 13, the one that we was able to prove in the slide before. So also you need to memorize this Pythagorean triple here. Let's write down the multiple of, let's say 10 of this Pythagorean triple. Then we know that for all right triangles, 10, a right triangle can have the dimensions of 10, 24, and 26. 26 being your hypotenuse. If I were, let's say, to multiply this Pythagorean triple by 3, that would be 15, 36, and 39. So again, that means you could have a right triangle with the dimensions of 15, 36, and 39. 39 being your hypotenuse, your C. How about if I were to multiply, let's say, 5? Then you can have a right triangle with the leg of 25, the other leg being 60, and then the hypotenuse being 65. A squared plus B squared will equal C squared for all of these values here. Here's another Pythagorean triple. 8, 15, 17. You can see that the one below it is just 8, 15, and 17, but times 2. So 16 squared plus 30 squared will equal 34 squared, And another one to memorize is 7, 24, and 25. So 7 squared plus 24 squared will equal 25 squared. A squared plus B squared will equal C squared. Find the area of this isosceles triangle. So if I know that this is an isosceles triangle, I know that those two sides are congruent, meaning this is also 10 meters. I can see that from here to here it's 6. To find an area of a triangle, we know that the formula is 1/2 BH. I know that my base would have to be 12 because we know that this side here is 6. So the base is 12, but the question is, what's the height? Because I've memorized my Pythagorean triples, I know that it has to be 8. Because watch, it's a 6, 8, 10 triangle. Let's go back. It's this triple right here. 6, 8, 10. 10 being your hypotenuse. So I knew that in this triangle right here that I'm going to shade in with my highlighter, that we use, it's 6 squared plus 8 squared equals 10 squared. 6, 8, 10. My height is 8, so now I know that the area of my triangle is, let's see, 1/2 of 12 is 6. 6 times 8 is 48. 48 squared meters. Your homework that you'll be getting assigned in class tomorrow is page 437, 6 through 27 multiples of 3, 28 through 31, 34, 39 through 48 multiples of 3, and 49. Don't forget to copy down your problems and show work. You will have class time to work on this assignment. Otherwise, if you want to work on it tonight, you can as well. But just remember then that you will need to be AR reading or working on other assignments tomorrow in class.